Hello students, we are solving the IB Math AHL past paper questions and today we will be solving the IB Math AHL May 2021 paper 3 time zone 1 question number 1. The paper 3s usually contain 2 questions. We will be solving the first question of this paper and we will be solving the second question in our next session. And you will be getting the links to all the previously solved questions in the form of playlists in the description area. So without any further delay, let us start solving question number 1. It contains a maximum mark of 27 and it says, this question asks you to explore the behavior and the key features of cubic polynomials of the form x cubed minus 3cx plus d. Consider the function f of x equal to x cubed minus 3cx plus 2. So the d value is replaced, the d is replaced by this number 2. For x belonging to the set of real numbers and c is a parameter, this c is another real number. The graphs of y equals f of x for c equal to -1 and c equal to 0 are shown in the following diagrams. You are seeing the two diagrams. So the d value is 2. So what are the function expressions for these two? C is -1. So over here, this one is f of x equal to x cube. Minus 3 times -1 is plus 3. So plus 3x plus 2. So this is the expression for this function graph. And for this one, it is x cube and c is equal to 0. So we do not have the middle term anymore, plus 2. Okay. So, and we are seeing that the y-intercept is 2 because we are having d value as 2. Therefore, the y-intercept has to be equal to 2. Whatever may be the value of c, the y-intercept will always be equal to 2 if d is 2. So the first subpart for this question number 1 says, on separate axes, sketch the graph of y equals f of x, showing the value of the y-intercept and the coordinates of any points with 0 gradient. 0 gradient means f dash x will be equal to 0. When do we have f dash x equal to 0? If we have a maximum point, or if we have a minimum point, or if we have the stationary point of inflection. That is the point of inflection where the gradient is 0. So these are the three cases when we have f dash x value equal to 0. So we have to give the coordinates of the y-intercept, value of the y-intercept rather, and the coordinates of any points with the 0 gradient for c equal to 1 and c equal to 2. Each contain 3 marks. We have to sketch the graph, and this is with calculator obviously, so we will be using the calculator. But first of all, we will be writing the expressions. It is x cubed minus 3cx. Let me show you once more. X cubed minus 3cx plus 2. So c is 1. So minus 3 times 1 is minus 3. So minus 3x plus 2. And for this, f of x equal to x cube minus 3 times 2. Minus 3c is minus 3 times 2, which is minus 6. We have found the two expressions and we will be just graphing these two. X cube minus 3x plus 2 will be our first graph. Okay, add graphs. X cube minus 3x plus 2. So it is x cube minus 3x plus 2. Enter. Okay. And let us get the maximum and the minimum coordinates because the coordinates for the maximum and the minimum points because they are having the zero gradients. And we of course know the y-intercept because it is 2. I don't want to get the y-intercept again. If you want, you may get it. But first of all, let me take the minimum. It is 1, 0, can be seen clearly from the graph. And what about the maximum? It is minus 1, 4. Okay. 1, 0 is the minimum point. Negative 1, 4 is the maximum point. So let me just write it over here. Negative 1, 4 and minimum 1, 0. Okay. And of course the y-intercept should be 0, 2. Okay. For this, first of all, let us graph both, let us graph them in our calculator and then we will be sketching them. So maximum x cube minus 6x plus 2. Okay. So, or should we be going to the next step? That is better. F2x, x cube minus 6x plus 2. X cube minus 6x plus 2. Enter. Okay, now the minimum has come down and the maximum has also gone up. So let us get the coordinates. The minimum point. Okay, previously it was 1, 0. Now it is 1.41 and negative 3.65 or 66 up to 3 significant figures. Okay, and what about the maximum point? Negative 1.41. Okay, the minimum is positive 1.41. Then minimum, for the minimum it is positive and for the maximum it is negative 1.41. The y coordinates for the minimum it is minus 3.66 and let us first of all write them. The maximum is negative 1.41, negative 1.41, comma 7.66. Minimum 1.41 and negative 3.66. And of course the y-intercept 0, 2. Okay. So you are having, you can see this is 2. This is 1, this is 2. For this one as well, this is 1 and this is 2. The y-intercept is 0, 2. Fine, now we have to sketch the graph. The two graphs in fact. This one is for C equal to +1. We need 4 the top, and this is 0. Okay, so 5 and take up. This one will be easy. For the next one, it will be a little more, well, manageable. Why not? Let me take the weird thing. This is better. Better. Can take this. It is x, y. This is 0. This is 1. This is -1. And this is 2. This is 3. -2, negative. -3. This is -1. This is -2. 1, 2, 3, 4. Okay. So one of the points will be this one. And another will be 1, 0. Another will be -1, 4. Okay. I should be getting the x-intercept as well. So let us go for this. This one is -2, or let us check. Analyze graph the 0. -2, 0. So these are the 4 relevant points. And now we are in a position to sketch the graph. It will be of this shape. We are practically copying, because we have seen the shape from the calculator. We are just copying that shape. Out of this shape. Okay. So this is the graph for C equal to 1. Let us now sketch the graph of C equal to 2. We need the 0 of this point as well. The zeros, there are 3 of them. This one, -2.6. Let me write the zeros. -2.6. And 339, so 0.34. Six, I have taken up to two significant figures. Okay, because it was 260. Okay, fine. And what about the third one? It is 2.26. 2.26. Okay. This is just, let me write 2.60 because I have taken every number so far up to three significant figures wherever we are having some decimals. So, fine, now we have to sketch c equal to 2. This one is c equal to 2. To sketch it over here so that I can see all the information that I have written over here. C equal to 2. And I have to get by 7.66 means 8, or I can take 9, 9, 10, and this will be 5. So 15. Okay. Let me try. 6, 7, 8, 9, 10, 11, 12, 13. Okay. 6, 7. And what will be the x values? Minus 1.41, 1.4. That is not a problem. But it should be 7, 6, 5. I have to take from 8. 8, 7, 6, 5, 4, 3, 1, 0. Will be 1, 2, 3, 4. Okay. I know very well that you most probably are not being able to see the entire sketch, but let me complete. You will be see. You can see the entire sketch. I'll be showing you. Right now, I have just drawn the axis. -1, -2, -1. This is 6, 7, 8. Okay. So now, of course, the y-intercept will be this one. And the maximum minus 1.41 somewhere over here and 7.66. maybe over here somewhere. And the minimum is 1.41 and negative 3.66, 1.41 and negative 3.66, maybe over here. And okay, let me just write the coordinates as well. But these also, let me write them. This was 1 comma 0. This is 0 comma. This one is negative 1 comma 4. This one is negative 2 comma 0. Negative 2 comma 0. This is 2. So we have plotted the maximum point, the minimum point, the y-intercept, now the zeros. Negative 2.6, maybe over here. And 0.34, maybe over here. And 2.26, somewhere over here. Okay. Now can you see the whole thing? I have not connected the points, but I have to connect them. I am trying to connect them. So somewhat of this type, of this shape. Okay. So this is the c equal to 2. This one is c equal to 1. You are seeing that for both c equal to 1 and c equal to 2, you are having one maximum and one minimum point. Over here, the minimum point is on the x-axis, and over here for c equal to 2, the minimum point is below the x-axis. And for c equal to 2, you are seeing the maximum point has gone up and the minimum point has come down. So we have answered the first subpart, that is the subpart A of this question number 1. Let us move on to the subpart B. Subpart B. Write down an expression for f dash x. It contains just one mark. And the expression for f of x is x cubed minus 3cx plus 2. X is a real number and c is a parameter. It is also another real number. So f dash x should be equal to derivative of x cubed is 3x squared and derivative of minus 3cx is minus 3c. Derivative of a constant, that is 2 in this case, is equal to 0. So the expression for the f dash x is 3x squared minus 3c. It contains just one mark. So we have answered subpart B. Moving on to subpart C. Subpart C. Hence or otherwise find the set of values of C. Hence or otherwise means you can use the information that we have got so far. We have been given 2 graphs, we have sketched 2 more graphs, and we have found the dash x expression. We are given the f of x expression. We can give the answers for the following subparts using the information that we have gathered so far, or otherwise means we can use some other method as well. Find the set of values of C such that the graph of y equals f of x has. It is containing 3 more subparts. The first subpart I is a point of inflection with 0 gradient and it contains just a single mark. Point of inflection means at that point the second derivative should be equal to 0. And not only should it be equal to 0 at that point, that value of x, the sign of the second derivative should also change around that x value. Then only that point is considered as a point of inflection. And since that point of inflection is having a 0 gradient, therefore f dash x should also be equal to 0. Okay. So first of all, let us find, since the second derivative has to be equal to 0. So let us first of all find the x values where the second derivative is equal to 0. Okay. So for that we have to find the expression for the second derivative. So we start answering the subpart I or subpart C. We get the second derivative expression by differentiating the first derivative, that is f dash x. 3x squared when differentiated with respect to x will be giving us 6x. And 3c minus 3c, it is a constant, so it is just its derivative will be equal to 0. So the second derivative's expression is just simple 6x. And since it is a point of inflection, the second derivative should be equal to 0. Since it is a point of inflection. Okay. 6x equal to 0 means x equal to 0. And you can see the sign will be changing. If you take x equal to -1, 6 times -1 will be -6. And if you take x equal to 1, 6 times 1 will be +6. So the sign of f double dash x is changing around the point x equal to 0. So it is the point of inflection. And since it should be having a 0 gradient, therefore f dash x should also be equal to 0 for what value of x? For x equal to 0. That means f dash 0 should be equal to 0. Okay. Since it is having a 0 gradient, therefore f dash 0 equal to 0. And what is f dash x? It is 3x squared minus 3c. F dash x is equal to 3x squared minus 3c. Therefore, f dash 0 is equal to 3 times 0 squared minus 3c. And f dash 0 is equal to 0. So this is 0. That means negative 3c is equal to 0 or C is equal to 0. Okay. The question was, find the set of values of C. For this, we don't have any set of values. We are having only a single value for C, where there is a point of inflection with 0 gradient. Let us see what was the graph for C equal to 0. You see, this is the graph for C equal to 0. This is the point of inflection. The curvature is changing. Over here also the curvature is changing, but this is not having any 0 gradient. Over here you are not having a point which is where the tangent line will be parallel to the x-axis. But for this case, definitely over here, if you sketch the tangent of the curve to the curve at this point, it will be parallel to the x-axis. So the gradient of that tangent will be equal to 0. So this is the graph where C equal to 0, where you are having the 0 gradient at the point of inflection. Clear? So graphically also we are seeing that our algebraic answer, the answer that, or the value of x, value of C rather, that we have got calculating is the same that is shown over here graphically. Okay, fine. We come to the second subpart, II, one local maximum point and one local minimum point. For one local maximum and for one local minimum, we are seeing for C equal to -1, there was no local maximum or local minimum. For C equal to 0, also no local minimum and local maximum points. For C equal to 1, there is a local minimum and a local maximum point. Similarly, for C equal to 2, you are having a local minimum and a local maximum point. If you want, you can use your calculator and you can take the values of C as 3, 4, any positive number or any negative number as well. If you want to check, you have been given the graph of C equal to -1, you can take C equal to -2 and check whether you get a minimum point and a maximum point for C equal to -2 or -3. At least you can check. If you are not sure, you may take the C value as -2 and check. At least you can take one of them and check whether you are getting any minimum or maximum points. You won't be getting. But if you take C equal to 3, definitely you will be getting a maximum and a one minimum and one maximum point. And you will be seeing that for C equal to 3, if you take the maximum point will be, the y coordinate will be more than 7.66. It will be moving up, and the minimum point will be less than -3.66. It will be moving down. Okay. So I'm not showing the graphs of C equal to 3 or C equal to -2, but if you want, you can check. Okay. So we are saying, and also these are just integers, positive integers, C equal to 1, C equal to 2. What if C is a fraction? C is a real number, so it can be a fraction. C can be equal to half, C can be equal to 1/3 or 3/4, any number, a fraction, proper fraction, that can also be possible. You may check. You may check. C is greater than 0. We are having two cases, C equal to 1 and C equal to 2. But between C equal to 0 and C equal to 1, what happens? You want to see? Okay, let us just check. The expression is x cubed minus 3cx plus 2. So this is for just checking purpose. Just writing, this is checking. This is not the answer to the subpart II. X cubed minus 3cx. So if I take C to be half, maybe 3 times half is 3 over 2, x plus 2. Let us check what is the graph of this. 3 over 2, I can write 3 over 2, or you can write 1.5 as well. So x cube minus 1.5 x plus 2. Let us see. X cube minus 1.5 times x plus 2. So enter. Over here also we are seeing that there is a maximum point, there is a minimum point, and the y-intercept is 0, 2. So whenever you are having the c value greater than 0, what happens if c is equal to -2? Let us draw one more graph. Let us check. This one is x cube. You don't write these. I'm just explaining, okay? -3 times c is -2. So -3 times -2 is +6. Plus 6x plus 2. Let us see what happens. X cube plus 6x plus 2. X cube plus 6x plus 2. Same shape. The shape that we have seen for c equal to -1. It is exactly similar to that. Okay. So you are not having any maximum point. You are not having any minimum point. You are not having any point where the point of inflection where the gradient is 0. So it is similar to c equal to -1. This is c equal to -2. So you can test for other negative values. You have time, you may test, but you will be seeing that the shape is exactly the same. Okay. And for c greater than 0, always whatever value of c you take, you will be getting one maximum point and one minimum. Okay. They may be above the x-axis, they may be below the x-axis. Like over here for c equal to half, we are seeing the minimum has moved above the x-axis. For this c equal to 2, minimum is below the x-axis, the maximum is above the x-axis. For c equal to 1, the minimum is on the x-axis. So we are seeing different positions of the minimum point. The maximum is every time we are seeing it is above the x-axis. But the minimum point is, we have seen it can be above the x-axis, it can be below the x-axis, it can be on the x-axis. Okay, fine. So now that we are sure that in order to get one local maximum and one local minimum point, the c value should be greater than 0. Right. But since it is containing we can write that from the graphs that we have sketched for c equal to 1, c equal to 2, and you can sketch some more graphs like c equal to half, c equal to 3. You can show that all of them are having one local maximum and one local minimum. So for c greater than 0, you will be having one local maximum and one local minimum. But since it is containing 2 marks, so you may not be sure that whether you will be getting 2 marks. Well, if you give 2 more graphs, if you sketch 2 more or 2 or 3 more graphs, first of all, they will be taking time. And many students are not sure that whether they will be getting the full 2 marks by giving some more graphs. So is there any algebraic method to get the c values where the graph will be containing one local maximum and one local minimum point. How do we get local maximum and local minimum points for those stationary points? These are named as stationary points. For these stationary points, the f dash x value should be equal to 0. And what is the expression for the f dash x? 3x square minus 3c. So we will be taking for stationary points, or let me write maxima. F dash x is equal to 0. And the expression is 3x square minus 3c. Therefore, 3x square minus 3c is equal to 0. Yeah. So 3x square equal to 3c, or x square is equal to c, or x is equal to plus minus square root of c. Now, if c is a real number, so c can either be negative, c can be equal to 0, or c can be a positive number. Okay? If since c belongs to the set of real numbers, c is either less than 0, equal to 0, or greater than 0. Okay? So if c is less than 0, then it will be an imaginary number. X will be an imaginary number because you are having a negative number within the square root. So x value will be imaginary. Then you will not be having any maximum and minimum points on the graph. X and y, they are real axis. You cannot plot negative imaginary numbers on real axis. So, but we are seeing that we are having maximum and minimum points. Therefore, c cannot be less than 0. Okay. If c is less than 0, then x is an imaginary number, which is not true. Because we have sketched c for c equal to 1, we have sketched for c equal to 2. We have found the maximum and minimum points coordinates. X values were perfectly real numbers. Okay. So we have seen that x values are real numbers, they are not imaginary numbers. If c is equal to 0, then x has a single value. Plus 0 or minus 0, they both are equal to 0. So it is having only a single value. Therefore, we do not have to separate x values for maxima and minimum. Okay. Therefore, c equal to 0 cannot be taken. Therefore, so the answer is c is greater than 0. The graphs for c equal to 1 and c equal to 2 confirms our answer. Okay. So we have completed answering the part I, and now coming to the subpart I. No points where the gradient is equal to 0. We have taken c equal to 0. We have taken c is greater than 0. The only thing that is remaining is c is less than 0. Has to be. And we have seen what is c equal to -1. No point where the gradient is equal to 0. That means there will not be any maximum point, there will not be any minimum point, there will not be any stationary point of inflection. So this is c equal to -1. This graph is not having any maximum point. This graph is not having any minimum point. This graph is having a point of inflection over here, but it is not having any zero gradient. Okay. So this is for c equal to -1, and we have checked the graph of c equal to -2. This one. So we are seeing when c is a negative number, c is less than 0, we do not have any maximum point, we do not have any minimum point, we do not have any stationary point of inflection. Okay. So the answer for the I, it is just a single mark question. You can write it as c equal to, sorry, c is less than 0. Okay. The part D. Given that the graph of y equals f of x has one local maximum point and one local minimum point, that means c is greater than 0. We have seen that. Show that it contains two subparts. I is the y coordinate of the local maximum point is 2 times c to the power of 3 over 2 plus 2, and it contains 3 marks. Okay. First of all, local maximum and local minimum, we had found the expression for f dash x, but still this is subpart I. This is the expression for f of x. So f dash x is 3x squared minus 3c. This should be equal to 0 for the maximum and the minimum point. So it will be 3x squared minus 3c equal to 0. So this is x squared equal to c and x equal to plus minus square root of c. We have found this in our previous subpart as well, subpart c, x equal to plus minus square root of c. Now, and c is greater than 0, of course. Now, which point is the maximum and which point is the minimum? From the graphs we are seeing, from the two graphs that we have drawn, we are seeing that the negative value of x is corresponding to the maximum point and the positive value of x is corresponding to the minimum point. For this, c equal to 2 also. And we have sketched most probably for c equal to half. Let us check. C equal to half. This is the thing. Again, you see for the maximum point, the x coordinate is negative, and for the minimum point, the x coordinate is positive. But if this is not enough, because the question contains three marks, so just by looking at x c equal to 1, c equal to 2, and c equal to half, if you don't want to conclude that the xc will be x equal to negative square root of c, because c is a positive number, x equal to negative square root of c will be corresponding to the maximum point, and x equal to positive square root of c will be corresponding to the minimum point, then what do you do? In order to find which one is a maximum and which one is a minimum, we have two ways. One is the sign diagram of the f dash, another is the second derivative. But since we do not know the value of c, c is a positive number, but since we do not know the value of c, sign diagram of f dash x will not be helping us in this case. We'll be having the two zeros, negative square root of c and positive square root of c. But what values should we be taking for the leftmost region? If I just draw the sign diagram, this will be, this is the sign diagram of f dash x. This is negative square root of c and this is positive square root of c. This part you can take x equal to 0. And if x equal to 0, you'll be having negative 3c, so this will be negative. But what value of x will you be taking for this region and what value of x will you be taking for this region? You have no clue. So it is better to go for the second derivative. What is the second derivative? It is just 6x. Okay. And when x equal to negative square root of c, if double dash of negative square root of c equal to 6 times negative square root of c, which is less than 0. So this is corresponding to the maximum. And when x equal to positive square root of c, f double dash of positive square root of c will be 6 times positive square root of c, that is greater than 0. So this is minimum. So we have shown that negative root c is x equal to negative root c is referring to the maximum point, and x equal to positive root c is referring to the minimum point. Okay. So now that we know the value of x for the maximum and the minimum points, we will be just substituting these values in the function expression to get the y value. So what is asked first? Maximum point. Okay. So y max is equal to x cubed. So it is negative square root of c whole to the power of 3 minus 3 times c times negative square root of c plus 2. So this one is root c is c to the power of half. Let me just write this: minus c to the power of half whole raised to the power of 3 minus 3 times c raised to the power of half plus 2. This one is minus 1 to the power of 3 is minus 1. So this is minus. And c to the power of half raised to the power of 3 is c to the power of 3 over 2. And this one is c to the power of 1 multiplied by c to the power of half. So this will be minus 3. C to the power of 1 plus half is 3 over 2. Plus 2. Okay. But I should be having a plus sign, sorry, because this is minus and this is minus. So there will be this plus sign. Okay. So this is minus c to the power of 3 over 2 and this is plus 3c to the power of 3 over 2. They are like terms, so we can add them and it will be 2 times c to the power of 3 over 2 plus 2. Let us see. 2 times c to the power of 3 over 2 plus 2. So we have shown, okay, shown. And for I, y min should be, in place of negative root c, we will be writing positive root c. That is the only difference. Minus 3c times root c plus 2. So this is c to the power of 3 over 2. We have seen, but we will not be having a plus minus sign in front. 3 to the power of 3 over 2. And this is also c to the power of 3 over 2. So this is minus 3 c to the power of 3 over 2 plus 2, which is equal to minus 2 c to the power of 3 over 2 plus 2. Minus 2 c to the power of 3 over 2 plus 2. Okay. So we have completed subpart D. Subpart E. Hence, that means we can use and we have to use, in fact. There's no or otherwise option. Hence, for C greater than 0, find the set of values of C such that the graph of y equals f of x has, again, 3 subparts, I exactly one x-intercept. It is containing, every one of them is containing 2 marks, each of them. So, okay, exactly one x-intercept. F of x is a cubic function graph, and since it is starting with x cube, the x cube term is a positive term. The shape of f of x is of this shape. It is not moving down vertically like this, but it is coming from the top left position and moving down this way. For C is greater than 0. You are having one maximum and one minimum point, so that is why I have drawn these maximum points. So in order to have only a single x-intercept, how can the graph look like? There are two options. For a single x-intercept, f of x, the graph of f of x, can be let me write for C greater than 0. For C less than 0 or for C equal to 0, even then the graph will be coming from the top right and moving to the bottom left. Bottom left. But you will not be having the maximum and the minimum point. Okay. So for a single x-intercept, the graph of f can be either of this point, either of this shape, like either of this shape. This is the first one, or it can be like this. Either both the maximum and the minimum points are above the x-axis, or both the maximum and the minimum points are below the x-axis. Okay. These are the two ways we can have a single x-intercept for a cubic function graph. But for the f of x expression that we have been given, the y-intercept is 2. If we take this shape, we will not be having the y-intercept as 2. It will be a negative y value as the y-intercept. So we have to take this. Since this may be A and this may be B. Since the y-intercept is 2, therefore, only shape A can be taken. Okay. And for shape A to be considered, we are saying that the maximum point is always, so far, for all the graphs that we have seen so far, which had the maximum point and the minimum point, the maximum point was always above the x-axis. The minimum point was above the x-axis for c equal to half. It was on the x-axis for c equal to 1, and it was below the x-axis for c equal to 2. Okay. So for this, we are seeing the minimum point is above the x-axis. If the minimum point is above the x-axis, the maximum point has to be above the x-axis, because the maximum point will maximum point's y value, the y coordinate, should be more than the minimum point's y coordinate. Okay. So if the minimum point is above the x-axis, the maximum point will be above the x-axis. Therefore, we have to consider the condition where the minimum point's y coordinate is positive number, is above the x-axis, means it is a positive number. Okay. So we have to take that case. And what was the minimum point's expression, y coordinates expression? Minus 2 times 3, c to the power of 3 over 2 plus 2. Okay. That is why they have said hence, because we have to use the subpart D's results. So minus 2 times c to the power of 3 over 2 plus 2. Therefore, y mean should be greater than 0, or minus 2 times c to the power of 3 over 2 plus 2. Plus 2 is the, because of the y-intercept, the d value is plus 2, so we are having plus 2, is greater than 0. So what will be the values of c? Find the set of values of c, that is the question. So this is minus 2 times c to the power of 3 over 2 is greater than minus 2, and we divide both sides by negative 2. So since we are dividing both sides by negative 2, the inequality sign will be changing. Okay. So c to the power of 3 over 2 is less than 1. And taking the 2/3 power of both the sides, we get, or if I just write this as 2 over 3, this is equal to c is less than 1. But okay, c is less than 1 is not sufficient, because we have to include c is greater than 0 as well. Because if c is not greater than 0, then we will not be having the minimum and the maximum points. So we have to include that. Don't forget. So we have done the subpart I, we have got 2 marks. I says exactly to x-intercepts. Exactly to x-intercepts means we have seen that if we can have this type of a thing as well. Let me show you. Exactly two x-intercepts. So we can have this type of a graph. These are just rough sketches. Two x-intercepts. This is A and another is B. But again, since the y-intercept is 2, therefore the B has to be taken. Because if we take this, the y-intercept will be a negative number. Okay? Okay, let me write this as A, that is B. And for the graph B, what are we seeing? The y-coordinate or the minimum point is equal to 0. Okay? What was the y-coordinates expression? It was negative 2 times c to the power of 3 over 2 plus 2. So, y minimum equal to 0. Negative 2 c to the power of 3 over 2 plus 2 equal to 0. Or negative 2c to the power of 3 over 2 equal to negative 2, dividing both the sides by negative 2, we get c to the power of 3 over 2 equal to 1, or c equal to 1. And we have seen the graph of c equal to 1 did have the minimum at the y-intercept, at the x-axis, on the x-axis. We have sketched the graph. You can see the graph over here as well. See, this is the graph of c equal to 1. The minimum point is on the x-axis. Okay. So this is the case where you are having exactly two x-intercepts. And subpart I exactly 3 x-intercepts. 3 x-intercepts. So c is greater than 0. We have taken two portions. C is from 0 to 1. And then we have taken c equal to 1. The other part that is remaining is c is greater than 1. It has to be that. How many marks does this contain? 2 marks. Okay, since it is containing 2 marks, we have to write y min should be less than 0. Y max is always greater than 0. We have seen, but because the y-intercept has to be 2, so the y max will always be greater than 0. But whether the y min is equal to 0 or greater than 0 or less than 0, that will be determining whether we are having the only a single x-intercept or two x-intercepts or three x-intercepts. Yeah. So y min is less than 0 implies negative 2 times c to the power of 3 over 2 plus 2 is less than 0, or negative 2 times c to the power of 3 over 2 is less than negative 2. And again, we are dividing both the sides by negative 2. So the inequality sign will be changing, and it is c to the power of 3 over 2 is greater than 1, or c is greater than 1. Because the question contains 2 marks, we had to do this calculation. Otherwise, c is greater than 0 and c is a real number. You have taken c is from 0 to 1. You have taken c equal to 1. The only other portion that is remaining is c is greater than 1. Okay. So this is the answer for the subpart I of the subpart T. Most probably we have completed not subpart T, but subpart E. And we have completed answering subpart E totally. We move on to the last subpart of this question, subpart F. Consider the function g of x equal to x cubed minus 3cx plus d. Okay. For all the previous subparts, d was equal to 2, but now this is just d. For x belonging to the set of real numbers, and c and d are also real numbers. Subpart F, the last subpart of this question. Find all conditions on C and D such that the graph of y equals g of x has exactly one x-axis intercept. Explaining your reasoning. Okay, fine. Now, T is it is a variable and it can be positive or it can be negative. If we just take this part, say h of x equal to x cubed minus 3cx. Depending on the value of c, the graph shape will definitely be changing, but doesn't matter what is the value of c. Regardless of the value of c, the graph will be passing through the origin, because when x equal to 0, h of 0 is equal to 0. So the graph will be passing through the origin 0, 0. Doesn't matter what is the value of c, whether c is greater than 0, equal to 0, or less than 0. And depending on the value of d, that 0, 0 point, that y-intercept will be moving up if d value is positive, will be moving down if d value is negative. Not moving, but rather I should be saying that the graph will be getting translated up. The point 0, 0 will be translated up when d value is positive, and the graph, the point 0, 0 of the graph will be translated down when d value is negative, because it is the vertical translation. From h of x to g of x, what is the transformation? The vertical translation. That is the transformation that is happening. Depending on the value of d, if it is positive, the graph translates up. If it is negative, the graph translates down. Okay, so the shape of the graph will not be changing depending on the value of d. The d is only for the vertical translation. The original x cubed minus 3cx, for every value of c, the graph of x cubed minus 3cx will be passing through the origin, and depending on the d value, it will be just translated up or down. Okay? When d is 0, it passes through the origin. When d is some other number, it is on the positive side of the y-axis, or it is on the negative side of the y-axis. Clear? So, we are seeing that for c equal to -1 and c equal to 0, the two graphs that they have given us, for c equal to -1 and c equal to 0, these are the two graphs. And you see for both of them, the the y-intercept is 0, 2, because the d value is 2. Originally, if you take x cube plus 3x, you ignore the plus 2, it will be passing through this point. And because of this plus 2, this point got translated to 0, 2. It moved up, it translated up, shifted up to the 0, 2 point. Similarly, over here, x cube, if you just take x cube, it will be passing through the region, and this is the vertical translation upwards by 2 units, and the point comes to 0, 2. So, doesn't matter what is the value of d, that will be just determining by how many units the 0, 0 point, the origin is getting translated up or down. But the shape of the graph will remain as it is. So we are seeing for c equal to -1 or for c equal to 0, and we have checked for c equal to -2 also. The graphs do have only a single x-intercept. Doesn't matter what is the value of d. D can be anything, but when c is less than or equal to 0, the graphs do have a single x-intercept. Okay, fine. So let us write that. As graph passes through 0, 0, depending on the value of t. The graph is vertically translated vertically translated up or down, up or down. But the shape of the graph does not change. Okay, so only one single x-intercept. So one of them should be definitely, therefore, okay, c less than or equal to 0, the graph of g of x should be having a single x-intercept regardless of the value of t. Okay. So now we come to c greater than 0, where we are having one maximum and one minimum point. And for that, we need a single x-intercept. So how can we, I have in fact shown it previously. These are the two cases where you are having only a single x-intercept. Previously, we had to take this a point because the d value was fixed. It was equal to 2. So the graph had to pass through that 0, 2 point. But now the d is variable. It can be anything. So we can take both the cases, both the maximum and the minimum points above the x-axis, or both the maximum and the minimum points below the x-axis. We can take both the cases. Okay. Let me draw the two cases once more. Both the maximum and the minimum values above the x-axis. This is the graph A, or the second possibility is both the maximum and the minimum values y coordinates are below the x-axis. Because now we do not have the restriction of d value equal to 2. Both can be taken. Okay. So, in both the cases we are seeing, we are having only a single x-intercept. Now, for this, the y coordinate of the maximum is greater than 0. It has to be, because the y coordinate of the minimum is greater than 0. So definitely the y coordinate of the maximum has to be greater than 0. So what condition should we be taking for this condition E? The y coordinate of the minimum point is greater than 0. So for condition A, y min is greater than 0. Here, y min is greater than 0, therefore y max has to be greater than 0. And what was the expression for y min? Y min expression was minus 2 times c to the power of 3 over 2 plus 2. Plus 2 was because the d value was equal to 2. Now, in place of 2, we will be writing d. So the expression will be minus 2 times c to the power of 3 over 2 plus d. If you want, you can do the whole thing, whole process we have done. You know how did we come to this expression, minus 2 times c to the power of 3 over 2 plus 2. You just, in place of 2, you just have t, and you will be getting in. If you want to deduce the expression one more time, you will be losing some time, in fact, but you can, of course, do that. If you don't realize actually that this is just the d value. When d value is 2, you are getting 2. When d is just the variable, you keep it as d. Okay, if you cannot visualize this, then you don't have any other alternative but to go through the entire process once more. I'm not doing that because I'm being able to visualize, and I guess you will also be able to visualize because you are the HL students. So minus 2 times c to the power of 3 over 2 plus t. Okay. Minus 2 times c to the power of 3 over 2 plus t. This is for c greater than 0. For less than or equal to, t value can be anything. Now, let us check for c is greater than 0. Do we have any relation between c and d values? So, what will be d? D is greater than 2 times c to the power of 3 over 2. Okay. So, when for condition A, for c greater than 0, either d is greater than 2 times c to the power of 3 over 2, or for condition B, for condition B, you are seeing that the y max is less than 0. If y max is less than 0, y min has to be less than 0. For this, we have to take the y max. Because y max less than 0 implies that y min is less than 0. And what is the expression for y max? The y max expression was this. 2 times c to the power of 3 over 2 plus 2. In place of plus 2, we will be taking plus t. 2 times c to the power of 3 over 2 plus t. So it should be y max is less than 0. Y max is less than 0. See the graph? For condition B, this one, y max is less than 0. And what is the expression for y max? It is 2 times 3 to the power of 3 over 2 plus t. This is less than 0. So d is less than negative 2 times 3 to the power of 3 over 2. Okay, over here we are having the relation between d and c and d, and we are having two cases. Okay, therefore for having a single x-intercept for the graph of g of x, either we can have there are two cases. C is less than or equal to 0. D belongs to the set of real numbers. D can be any value. D can have any value. Or C is greater than 0 and A t is greater than 2 times c to the power of 3 over 2. 2 times c to the power of 3 over 2. And b is less than negative 2 times c to the power of 3 over 2. This is the answer. Okay. Okay. So this is our final answer for the subpart F. We have completed question number 1 of this paper 3. So, and we will be solving question number 2 in our coming session. And I'm Nilanjana Sanyal. I tutor IB Math A, SL and HL level students inside India and outside India. And I'm starting my group online math tutoring sessions for IB Math A, SL and HL level students. And if you are interested in joining my classes, you are seeing my email ID, you are seeing my WhatsApp number getting displayed. You may contact me for more details. Okay? And thank you for staying with me till the end. And we meet again very soon in our coming session with the question number 2. Till then, bye.